Hello, sixth graders. Welcome to sixth grade math Shapes of Distributions lesson. Pause while you write the lesson title in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is, I can use data displays to identify shapes of distributions by completing practice problems with 100% accuracy in multiple attempts. Today's standards that we'll be addressing are interpret numerical data by creating a histogram, box plot, and/or dot plot, and summarize numerical data sets in relation to their context by finding measures of center, variability, and overall patterns. We're going to start by taking a look at the key ideas. It says you can use dot plots and histograms to identify shapes of distributions. So once you put your data into a dot plot or a histogram, you can kind of see the shape. This also works for a stem and leaf plot. So the words or the definition for a distribution that is skewed left, and this kind of got cut off, so I'm going to fill in the rest of the letters here for you. That's skewed left, is that the tail of the graph extends to the left and most of the data are on the right. So the tail goes to the left and so it's skewed left. Symmetric, the left side of the graph is a mirror image of the right side of the graph. And it doesn't have to be exact, but it would be pretty close. So it would be a symmetric graph would be close to a mirror image. And then skewed right, as you might have guessed, is when the tail of the graph extends to the right and most of the data are on the left. So be sure these make it into your notes because they're super important for this lesson. Now we're going to take a look at example 1A. We're describing the shapes of distributions, and it says describe the shape of each distribution. So I just have one on the page for you right now. So we have daily snowfall amounts, and if we take our pencil, or in my case my stylus here, and I draw sort of an outline of this, we can see that the tail of the distribution is on the right. And so that means most of the data is on the left. So since the tail is on the right, the distribution is skewed to the right. So when you go to write your steps in your notebook, you might want to say that you look at or outline the shape of the distribution and see where the tail is. We're going to move on to example 1B. We're looking at passes thrown in a football game. So this is a histogram, and we can see the shape of this. And so it says the left side of the graph is approximately a mirror image of the right side of the graph. So there's that word approximately again. So it's not exactly a mirror image. You can see like at the end, the 50 to 59 and the 10 to 19 aren't exactly the same height. And there's a couple of other little differences, but they're very close. And there's not an obvious tail. So that means that they're a mirror image so they are symmetrical. So you could, if I could find the middle, you could draw a line right down the middle, and the distribution is symmetric. In example 2, we are once again describing the shape of a distribution, and this is a histogram, and it says the frequency table shows the ages of people watching a comedy in a theater. Display the data in a histogram. So our first step is to make the histogram. which you have learned how to do, and then describe the shape of the histogram. So it's asking us to actually do two things: display the data and describe the shape of the histogram. So it says draw and label the axes, then draw a bar to represent the frequency of each interval. So that is all in our step 1, making the histogram. And then step 2, we need to look at the shape. So I like to outline it because it really shows that curve. So we need to identify the shape. Let me erase that. It's a little messy. There we go. Oh, my pencil got that. And we can tell when we look at the shape that it is skewed. We've got the tail on the left, so that means it is skewed to the left. So this is 2 steps and 2 directions, so it's kind of one for each part. And now for example 3A, we're going to compare shapes of distributions. So it says the histogram shows the ages of people watching an animated movie in the same theater as in example 2. So we're going to describe the shape of this histogram. So once again, our step is to outline this and look at that shape, and we can see that our tail is on the right, which means that our distribution is skewed right because most of our data is on the left. And now let's look at example 3B. We're still looking at that same animated movie attendance that we looked at in 3A, and it just asks us which movie has an older audience. And it says the intervals in the histograms are the same. Most of the data for the animated movie are on the left. So we started with younger ages on the left, while most of the data for the comedy are on the right. So if you recall, the comedy ages skewed the other direction. It went like this. This means that the people watching the comedy are generally older than the people watching the animated movie. So the comedy has an older audience. So when you're thinking about your steps for solving this problem, it is to compare the distributions of the animated movie and the comedy. So that's what you need to put in your notes. And you will know you are done with this lesson when you have completed your notes in your ISN, completed your Google Form questions, reviewed the lesson if you need to, and completed your Big Ideas math assignment in your Math Spiral notebook, and submitted that when it's 100% correct and not before. Be sure to track your progress on your playlist.